Now we are going to look at volume of cylinders, which is also found in 13.1 in your book. So again, looking at the Keystone formula sheet, so here's your cylinder. We are looking at volume for this video, so we are going to be using this formula. So pi, r being the radius squared times the height. So first example, let's find the volume of this cylinder. So volume is pi radius squared times the height. In this particular picture, this 1.8 is representing the radius, and this 1.8 that is perpendicular is representing the height. So pi 1.8 squared times 1.8. Just like in the surface area video, I'm going to express my answer first in terms of pi, and then we're going to express our final answer to the nearest tenth. So if I take 1.8 squared times 1.8, I get 5.832 pi. That would be your exact answer. Rounded to the nearest tenth, we would get a volume of 18.3, and we are measuring in cubic centimeters. So next example, we're going to find the volume of this oblique cylinder to the nearest tenth. Oblique just means that it's tilted a little bit. So when I look at this picture, we see this tilted cylinder. This 11 is still representing my radius, and I still want my height to be the perpendicular height, which is represented by this 44 centimeters. So volume is pi r squared h. So substituting in pi, radius of 11 squared, and height of 44. 11 squared times 44 gives me 5,324 pi. That would be your exact answer. And to the nearest tenth, that would be 16,725.8 cubic centimeters. Okay, and last example, when I look at this example, so we have our cylinder, and let's notice some of the labels here. So 10 is across the entire circular base here of this cylinder, so that 10 is representing my diameter. And so my radius then is half of it, and my radius would be 5 centimeters that I'm actually going to use in my volume formula. And this 13 is representing this diagonal length. So that's not representing the height. We are going to have to find the height. So if I draw in, and I'll try to make this dark, these lines here, keeping in mind that our height is perpendicular, I know that this length is 10. I know that this length is 13. I want this height to be perpendicular. So I formed a right triangle. This is 10. This is 13. This is the height that I want. And I'm going to use Pythagorean theorem to help me find that height. So 13 is my hypotenuse, 10 is one of the legs, and the height of the cylinder is that other leg. So if I do h squared plus 10 squared equals 13 squared, I get h squared plus 100 equals 169. And if I subtract the 100, h squared equals 69, and the height is the square root of 69. The square root of 69 does not simplify, so we're going to leave it just like that to substitute in until we get to the nearest tenth, which is what we're going to round to for our final answer. So then volume is pi r squared h. So pi, the radius we said was 5, so 5 squared, and then this height is the square root of 69. So if I go ahead and multiply this 5 squared times the square root of 69, I'm just going to round it to the nearest hundredth. So I would get 207.67 pi in terms of pi. And then we'll multiply that out, round our final answer to the nearest tenth, 652.4 cubic centimeters. And that is all for volume of cylinders.